longer than 15 minutes at less than 1 milligram per liter, and that was my call off on that. And we were operating on one blower, and the lowest point when he ran that test was 45% speed, so he actually had it at the lowest, and it didn't cause any problems with the process. Granted, we weren't doing it for a long period of time, but the key thing is, you have dissolved oxygen available to the microorganisms. You gotta remember, when you look at DO is the residual oxygen that's still available for those organisms. But, you have a power outage, something like that, you guys bounce back from, if a blower goes down for a while, you have no oxygen going in there for a while, it'll bounce back pretty quick. I wouldn't want to tempt fate, though. We were very fortunate when we were doing that one blower test that we ended up 2 on that one day, just because you had a precipitation event and your oxygen demand wasn't very high to begin with. This is something to kind of know. So we already know about an oxyzone, it's less than 0.5 milligrams per liter DO. And like I said, I've been seeing 0.1, 0.2. And you're going to maintain anaerobic zones, anaerobic, no nitrate or DO. So you have no DO in your anaerobic zones. Internal recycle rate, optimize it, pH, alkalinity. Supplement your alkalinity with incinerated scrubber waste and hydroxide. Nitrification of phosphorus removal, most sensitive to the process mechanisms. And we're going to go through that one. Let's see. All right, here we go. Nitrification inhibition by metals. These are the metals and the inhibitory concentrations. So, I don't know if you guys have any heavy metal industries, but if somebody was to dump a tanker of some treatment liquor from a metal plating facility or what have you, and any of these metals made their way in, these are the levels at which they would be inhibitory to the nitrifiers, okay? So that's something kind of nice to know there. Things that can affect your phosphorus removal, you gotta keep the DO above 1, but you want to definitely go for 2. Same thing here, you want to keep your pH below 6.5, phosphorus removal is going to be greatly reduced. We keep saying around 7.2, 7.2, if you're banging around neutral, you're good. Then these are cations, having molar ratios of these cations, magnesium, potassium, calcium. If you already have a deficiency of these, would cause problems, but again, most municipal wastewaters have sufficient amounts. All right, so these are the cations that would be of concern if you were deficient in them. All right, waste sludge control. Obviously, you want to maintain a wasting balance between the BOD loading and the primary effluent amounts, types of microorganisms available to treat the loading. And a portion of the activated sludge inventory must be removed regularly because your microorganisms are constantly reproducing. That portion must be directly proportional to the new growth from the consumption of the food, basically that's coming into the primary, from the primary effluent, the BOD, minus the natural decay and loss in the secondary clarified effluent. And that's accomplished with the SRTA calculations. That's the SRT aerobic calculation. So in this, you're going to use the aerobic volume that's out there. So if you're running the A2O mode, you would not use the anoxic selector or the anaerobic selector's volumes in the calculation. You'd use only just what's aerobic. And so if you're consistent with that, that's how you can calculate your efficiency. It's basically the same as the regular SRT calculation, except that your volume used for your reactors is the only aerobic one. And I think you guys are pretty much familiar with the pounds formula, 8.34 times million gallons, or volume, times your concentration milligrams per liter. And that's what you end up plugging in to get your pounds for your MLVSS, to be divided by your VSS wasted per day, or added to your any VSS that you lost in your effluent per day. Okay, you guys have a hydraulic wasting box, and this is really cool because these hydraulic wasting boxes on each battery, what they do is they allow you to hydraulically waste mixed liquor suspended solids instead of wasting from the RAS discharge lines, okay? And what you'll do is you set the WAS pump flow rates manually to maintain the SRT. So for a 10-day SRT, you just calculate 1/10 of your aerobic volume and set it to waste that amount, and it automatically will be maintaining an SRT of 10 days. So this is a very foolproof, simple way of doing it. You know, I don't have to sit around and keep cracking numbers, just going by volume. And so if you have the SRT, if you're going to increase it over 10 days, the current mode of wasting, which you used to use back in a way, was off the RAS lines, would have to be employed. And that corresponding flow would be greater than the capacity of the WAS pump. So then you're going to end up wasting off of the RAS line of a more concentrated amount of white ordnance. Similar to your wasting operation, your wasting either mode is going to expect to occur 24 hours a day. Your hydraulic wasting is fed from gates on the north and south located in the hydraulic wasting box on each of those batteries, so you set up the gates. You also have the ability to open a gate and let scum get diverted and mixed in there as well to get rid of scum that comes off the top of the aeration tank, so that's something you can routinely do as well. And it's an 8-inch line that will take your mixed liquor from that wasting box, goes through the WAS pumps, and from there the pumps will send the WAS over to the DAF units. Obviously the pumps couldn't be located upstairs, which is where they used to be, so they're set down into the basement of the pump stations. Thus you can use gravity to feed the suction side of the WAS pumps. Okay, sludge wasting more than any other activity affects the process control of the activated sludge operational mode. You've got to get the SRT for the process that you're employing. So if you have too low of an SRT, you may not encourage the growth of the selective microorganisms that you need to perform nutrient removal. All right. Poor and consistent wasting program can adversely affect the growth rate of activated sludge inventory, oxygen consumption, MLSS settleability in final settling tanks, foaming, nitrification, nutrient removal, and overall effluent quality. So wasting is very important that it be consistent and that you're maintaining the SRT for the process that you're employing. Okay, so now we get into the south battery startup. We're currently using tanks 3 and 4 of the north battery, the final settling tanks 5, 6, 7, and 8. What we're looking at doing, I don't know about tomorrow, we'll see. Is to get the south battery aeration tank number 1 put online, and eventually, it's gradual, work up to 6 to 8 final settling tanks to be put online for a short period. There's going to be installation work that has to be accomplished over aeration tank number 2. After 7 days, aeration tank number 3 is going to be taken offline for cleaning and repairs, and also aeration tank number 2 will be put online while number 3 is drained. Aeration tank number 4 will be taken offline, and that aeration tank will be cleaned and inspected, and aeration tank number 2 will be put online. And then aeration tank number 4 will be cleaned and inspected while number 3 is put in service. Final settling tanks 5, 6, 7, and 8 will be gradually taken offline, cleaned and inspected, while the south battery final settling tanks are put online. At one point we're talking even having all 8 final settling tanks maybe online.
For a short period of time this summer or fall, you will see that. And we'll eventually operate 3 trains, which the train being 1 aeration tank and 2 final settling tanks. But what we're trying to do is inspect the entire north side before winter. We will not inspect the south side before winter. We'll let that run for a year, and we'll inspect that next year.
Yeah. Because it's, you know, at least you have definitely a good year on the north battery now. And they can go in there and make sure, you know, there's nothing oddball down there in tanks 3 or 4 and broken diffusers or, connections that come loose. And they've already got, there is, some work that has to be done anyway, so they can identify aeration tank number 3. There's, some couplings that have to be repaired. You know, obviously, the same thing with the final settling tanks. We wanna make sure that there's nothing, any problems with, North Battery final settling tanks with the structure beneath the surface. Yeah. So, that's it in a nutshell. Any questions, comments?
I disagree with one of the statements on the hydraulic hoisting. And that's the box that says if the SRT increases to over 10 days, the pump hoisting would need to be employed, which means they're coming off the rise line because if the pumps wouldn't have enough capacity. I think that's just the opposite. If you increase your SRT, you need to waste less volume. And based on that, you have more capacity with your pumps. So I disagree with that statement, but I respect your ability to make that statement. Okay.
I'm open to changes, guys.
Be glad to discuss that with you at our next coffee breaks.
Okay, sounds good. Any questions about how things been running out here? You guys had, Wet n Wild out there Thursday with all the water. Until, we get the South Battery online, because that's gonna definitely, take a lot of stress off operating the plant. Because, you know, gone this far, especially as rainy as it's been, this has been nuts. Although it's not the rainiest, June.
Yep. We've had one wetter June, that's when Jay came to the district, and we thought it might be a sign. But it wasn't a sign. Jay works out well for us. He fits into a dysfunctional family we're in, actually.
All right, well, hand it off to Jane. Thanks, guys.
If I see anybody sleeping, I'm
Hey,
going to
Jane?
put them out.
Do you want to be in view or out of view?
Out.
Okay, you're good.
Let me think.
You're good. Hold on just a sec. Okay.
And just so you know, if I pop in like this in an hour, you can second kick me out. Or if I pop in like this, so you've got it.
Yeah.
I don't want to distract them. And can you see that?
What's happening now?
That looks
This
good.
is live, yeah. If you
That
want.
looks good.
Everybody is just itching to control. Jump off.
Where you are right now is good.
Okay.
Are you
Figured I'd
using?
stand up just because I know you're going to me. So, and I can see who's falling asleep in a point.
What do you have to know good, I can see
Will
now.
that bring your eyeballs out?
Huh?
Will that bring your eyeballs out?
Yeah, I won't.
Well, trust me.
You see that across the table, and you have to know good.
Somebody should acknowledge that.
Okay.
Get rid of the shit.
All right, so I don't, one thing I want, is everybody ready?
Jane, when you want to use the mouse and change something, you're better off sitting down
Okay.
and then doing it, and that way you won't be
Okay,
in front.
but I won't get in this. Okay, first here's the agenda of the class. I wanted to talk about the format of the class. You've had a couple of training sessions, and so I'm seeing this as both a follow-up to the north side startup and an introduction to the south side. And what I wanted to let you know is that we're going to have a follow-up when everything is started up and tuned, and we've made our adjustments. We're going to have another follow-up training. It'll be a short one, but it will be to go over the inevitable changes that we're going to make while we're in startup. And the reason we do that is, you know, we've got, you know, controls are very hands-on, and there's a lot of user preference that's involved in it. You know, we want the controls to fit the way you operate, your standard operating procedures, what's important for you to look at, and so there's naturally a lot of changes. Plus, there's things that we just don't anticipate. We try to anticipate all the conditions that are going to be, you're going to encounter in the field. And a lot of times we get way too creative with those conditions and you never encounter them. And so we sometimes decomplicate the controls because the conditions that we were worried about don't happen. Sometimes there's some conditions that we didn't anticipate that we have to adjust for. So that's why there are control changes. And so we'll have a follow-up a class on just the controls. We'll probably do some operating, another O&M, process type controls. So we'll be working, Georgina and I will be working together again. But that doesn't mean you can sleep through this class. Because what I would like to do is, you've had some operating experience on the north side. And so now is a good time for you to give me feedback on things that are not working well, are working well, questions you have. So it should be more interactive, so, as we're going along with things, and as you can see, we can actually look at your live system right now and play with things, not play with things. There's a simulation on the blowers that we actually can play with the blowers. They're offline. So keep that in mind as we're going through it. So I'm going to start with just a really quick review of the SCADA standards. I think you're all familiar with this, but we'll walk through them just if some questions have been coming up while you're going through operating, so everybody's on the same page. And there's some things that I discovered about, RSView, and which, by the way, between now and the end of the project, we're going to upgrade the SCADA system to a new revision, so there'll be some changes. It won't be a lot of changes to your screen. There'll be no changes to your screen. Oh, you see my hand? There will be a lot of changes in some of the functionality, so it's going to improve the functionality, and a lot of it will be like alarming, trending will be better, logging of operator actions so that you can say, oh, was that valve in manual? Is this the reason that, this didn't start up? Or when did it go to local mode? So there'll be some changes in that. So that will be part of your last class. So, review of the SCADA standards. I think the colors are they're very consistent. Red is energized, essentially. So red is running or the valve is open. It's also an alarm condition. If you have an alarm condition, that will pop up. So I'm sure you've seen that box and it flashes. Green is closed or not running. So that's supposed to be your shelf state. Maybe less obvious, yellow means an abnormal condition. It's not necessarily an alarm, but it's something that is abnormal. So if you've got a valve in local, it generally shows up in yellow. The normal condition is purple or magenta. That's purple to me. The thing to note too is, yeah, the white box means that's a set point that you can enter, right? So if you see anything in white, that means you can click on that box and enter a set point. The red box means that is what the SCADA system is actually using as the set point. Ideally, they should be exactly the same, but if for some reason you're not communicating, your screen is not communicating with the PLC, they may not be the same. And anything in a black box is actually a measurement from the field. So in this case, So in this case, the position of the valve is at 62.9%, and there's your flow. So that's what those mean. The output being on means that the PLC is telling that particular piece of equipment to run. So are there any questions about the colors? So right now you can see at a glance which mixers are running, right, because they're red, which mixers are down. Online, okay, everybody get that? And actually this is what we were just looking you've seen that have puzzled you before? Okay. So we'll just walk through how to navigate. There's a few things that I wanted to point out that you may or may not know. So you've got your main menu, your header elements, footer elements, set points, trends, and alarm history. So to get back to the main menu, you always just go up to your logo here and click on that. And that'll take you to your main menu. And within that, you may have some sub-menus, but generally, you can click on anything here and it will take you to that area. Here's my favorite one. I'm gonna check out. So there's your blowers. So that gives you an overview of the blowers, whether they're running. One thing you may have not noticed is if you are logged in as a senior operator, you could possibly go to the service display. You want to use this very sparingly. I mean, you really shouldn't have to use it too often, but if for some reason the blower, you're having problems with the blower, you can go to service mode, where this will show you that this is in service mode. We don't really give you, the reason we did that is we were having trouble with these discharge valves. They wouldn't close fully, and so then you couldn't start and stop the blowers. And the valves are way up in the air. So you'd have to go get a ladder and go and operate these things, and that's not very safe. So we gave you the opportunity to put it in service mode, exercise that valve. So if a blower's been offline for a long time, that valve may not close fully, or it's closed, but it just didn't come down hard enough. So that gives you the opportunity to open and close that and then put it back in normal. When you put it in service mode, it's not going to start, and it will trip it and do that. You can also do a fault reset from here. You don't want to do that in normal conditions. I mean, if something on the blower trips and gives you a fault, the idea is for you to go to the blower, check out the Turblex alarm summary. It'll tell you what tripped you, and then do the reset from down there. And the thought is that if there's something that tripped it, you physically want to look and make sure everything is okay with the blower before putting it back online. So any questions about that? The service mode is really just to exercise the discharge valve in case it doesn't open properly.
Sometime in the future, Jane, you're gonna add number 4 to that service mode?
Yeah.
Yeah.
Number 4 was offline when we were doing that. So
Understood.
we don't want to write that down. Another thing that we added that was just useful in troubleshooting is the trends. You've got lots of trends on the individual blowers, so just put all 4, the capacity and the amps on here. We were really looking at this just to see which ones were running together and what the total capacity was. We were using this to see what your diurnal trends were, so we could do tests. But I thought it might be useful. I'll just keep it up here. So you can see that the capacity and for each 1 and 2, 3 and 4. You could also go to the second page on that, and it's all the motor amps trended together. So if you've got 2 or 3 blowers running together, you can see the total. Again, we were doing that for these blower tests and to assess how they're performing. Set point. For most of the processes, if you're logged in again as a senior operator or somebody or someone like me, you can actually put alarm set points in. So if you want to adjust when you get an alarm, when you get low DO, you can do that, or high flow, you can do that from this page right here. So that's your process alarm set points, essentially. A couple of things about the trends I wanted to point out. Hopefully you're probably familiar with them, but there's some tools like this trend right here is for 24 hours, 1 day. If I wanted to change that, I can right click on it and then select chart properties. And so if I wanted to see more detail, I could go to 1 hour on that and go to OK. And you can see that that changed that for 1 hour. That's temporary. As soon as you move off this graph and come back, it'll open up with its default, and in this case, it's 1 day default. And you can scroll back. This scrolls back half the time that you're showing, half the span, so 30 minutes or an hour. And once you move it just even once, you can go back to chart properties, and say if you wanted to go back to April and find out what was going on, and you didn't want to have to sit there and click back, 60 times, you could just go right to April. Did everybody know this? Is everybody aware of this? I don't want to be bored. Okay, good. All right, I'm glad I'm on that. So I could go right to April, and there we go. I don't have to click, 24, 60 times or whatever. I just go right back, okay? Then when I'm done with that, you can see that it's paused right now, so it's not updating live because I'm looking at history. So when I'm done with that, I can go to the most current date, and we'll come back to that time. And if you noticed, now I'm left clicking, I'm using the left mouse button. If I see something interesting and I want to know what is going on right there, I can click on that and you can see all the values are coming up on that white line, and it tells you Tuesday, July 7th at 9:23, the IR number 1 pump, this is not a very interesting one, graph, sorry, was at 0, so you can see exactly what was going on. If I just hover over a line, it'll tell me a lot about that. It'll say the aeration tank number 4 valve position was at 90. If for some reason I want to know the tag name, because say you're working with an instrument, instrument guy in the field, and you're having problems with a measurement, and you're trying to tell him at this time it keeps dropping out, and he'll say, what's the tag name? And all you're getting is the descriptions. If you just hover over that description, it actually even gives you the tag name, so you can tell somebody that is interested in the tag name, and it usually would be an instrument guy that's trying to go out and troubleshoot that here's the tag name. And you notice the scale right here. Right now it's 0 to 100 for the pump speed. So, I can say, okay, that's about 90%. If I want to know what the scale is for the aeration flow, I just click on that and see how it changed to the blue. So it gave me the scale. So the trends have a lot of tools with them, and even if you knew it and you haven't worked in it in a while, just kind of a reminder of what the trends can do. So they're a very good, useful troubleshooting tool. Any questions about trends? And if I'm boring you, let me know. I know you're just saying, yes, I would rather be here than anywhere, right? Alarm history. I think many of you know how to use this.